Okay, so now let's talk about standard deviation and variance. The standard deviation is a number that should always be reported with the average. If the average is reported, anybody who is a good mathematician will also report the standard deviation at the same time. Your standard deviation measures the spread by figuring out or looking at how far your observations are from the mean. So, for instance, if you have the average, let's talk about trick-or-treating, right? You know how usually it's all like the same size, fun size candy bars? So if I were to weigh each individual piece of candy from my kid's candy bag when on Halloween, the standard deviation is probably going to be pretty small. The average might be around an ounce and a half, and the standard deviation might be 0.1 because all of the candy is pretty similar in size, okay, or similar in weight. Whereas if I were to measure, get a data set of all the NFL football players' salaries, right? Their salaries are all over the place. They go from 200,000 to 25 million. So the average, I don't even know what it would be, but the standard, maybe the average is a million, right? $900,000. But the standard deviation is going to be massive because those data points are spread out so far from each other. Okay. On a test, if I have an average of 75, a class average of 75, and a standard deviation of 3, I have a really good idea of where everybody did. 75 is the average, standard deviation of 3, they're all kind of clumped up, pretty close right around that 75. Whereas if I have a standard deviation of 15 and an average of 75, well, then really my students performed kind of all over the place. Their data points were more spread out. Your variance is literally just your standard deviation squared. So you take your standard deviation, square that number, and that's your variance. So you can report the standard deviation. You could also report the variance. It doesn't matter. So if we look at this example, let's say that this is the number of months before paint begins to chip. You paint the walls in your house. You don't want the paint to chip off. That's really frustrating. So notice I give you brand A and I give you brand B. I already did the averages. Add them up, divide by 6, 35. Add them up, divide by 6, you get 35. So these two paints have the same average. But what happens is when I scroll down, when you graph them, all of my paint A's are here and my paint B's are here. So which is going to have a bigger standard deviation? Brand A, right? Because brand A is more spread out. If I'm going shopping, both brands can report a true average of 35, but brand B would be wise to also report their standard deviation is very small. I have a good idea of how long my paint is going to last before it starts to chip. Brand A, I might get lucky and it waits 60 months, but I could also get only 10 months and that would be terrible. So I, looking at this, would much prefer to buy brand B for my paint. How we come up with this, now we're getting into formulas. This is on your formula card, okay, but you rarely need to compute this by hand. You would take each data point, x, subtract the x bar, the average, square that answer, and add up that for all of the data points. So like in this problem, you had 6 data points for A, so you do this x minus x bar squared for all 6 points, add up all of those, and then divide it by 6 minus 1. All right, we have S. S represents your sample standard deviation. S squared would represent your sample variance because your variance is your standard deviation squared. Or you could look at it as the square root of your variance is equal to your standard deviation. You could look at it either way. Sometimes problems will report the variance, so you know you need to square root it to get your standard deviation. Sometimes problems will report your standard deviation, so you know you need to square it to get your variance. If you have a population, then the symbol is lowercase sigma. This is like a little circle, like a Phillies P on its side or a 9 on its side. So you draw it whoop like that. So lowercase sigma, not the big capital E looking one, but lowercase sigma is your population standard deviation. Sigma squared is your population variance, right? Because again, that whole standard deviation squared is your variance. So If you need to compute it by hand, you can, but if you come back to our list from here, it actually calculates it for us in here. If the data, now what happens is they actually give us both, okay? So what you need to know is, did you type in a sample? If you typed in a sample, then you would use this S, sample standard deviation. If you type in a population, then you would use this. They have a slightly different formula. You don't need to know the formula for a population because you almost never have every single data point for a whole population, right? That's really hard to find, which is why we deal with samples so much. So this is typically the standard deviation that we have, right? Our sample standard deviation. So this is typically what you would use. So you don't, if you need to find it on your own, absolutely throw it on the list, one variable statistics like we did. But if you can't find it on your own, right, you could use this formula. It's just really annoying to do, but you absolutely could do it. Now let's talk about how to, like, we have all these pieces of ways to measure, but how do we decide what's the right one to use and what's not the right one to use? All right, so if we look here, we want to use our 5-number summary, okay? If our data is skewed or if we have something with strong outliers. So if you have skewed information, okay, skewed data set, skewed left or skewed right, where you've got strong outliers, then you really should be using your 5-number summary. You should be using your median and your IQR. If a problem asks you to describe your data, right? Remember how I talked in the histogram video about how you have to talk about center, shape, spread, and outliers? So your center, you either need to talk about the mean and the standard deviation as your center and spread, or you need to talk about your median and your IQR as your center and spread. Now we're going to be more specific than before where I was like, it's right around 6. Now we should be able to calculate. So if you have symmetric distributions, you don't have outliers, it's looking pretty symmetric, you're going to use the mean and the standard deviation to discuss. And the reason for that is I already described it. Your mean and standard deviation are affected by outliers. My Aunt Wilma or my brother-in-law, okay? They'll change the average height. They'll change the standard deviation, right? Because they'll change how spread out my data points are. But then if I have something that isn't, like if we don't have outliers, then mean and standard deviation are totally fine to use. But if we have a data set where we do have outliers, then they are not okay to use, all right? Not even close. So what I want you guys to do is I want you to practice typing in, like pause the video right now, try number 3 on your own of putting in your data set. I will model it in a minute, but take number 3, you're going to type in males and females, okay? And we want to decide if we're comparing the texting habits of males and females, all right? So I want you guys to put in males as a data set in column A, and column B, put in females as a data set. And I want you to come up with box plots, like do your 5-number summary for both males and females, all right? And then go from there. I'll show you now, all right? But pause it, do it on your own, and then restart the video. As you look here, all right, I don't need fat anymore. Now you have choices. You can either clear this out, so you can go up to the top, right? So I'm here, I go up, up, up. Now that it's highlighted, I can just hit delete. And then I go to the left, up, 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 delete. Go to the left, up, 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 delete. Okay, I'm going to type in the males data set. Where'd it go on my paper? So males. I'm going to go up top. I'm going to call it males. I'm going to go up again and I'm going to sort it. So menu, actions, sort. Okay, I'm going to type in females here. I'm going to type in the female data points. All right, it's okay that they don't match. All right, that the males, there were 15 sampled, females, there were 16 sampled. Your samples do not have to be the same size all the time. There are some cases where they do, and I'll explain those later, but for now, it's fine that they're different. So I want to do my one variable statistics for both of these. So I'm going to put my cursor in the males. I'm going to go menu, statistics, stat calculations, one variable statistics. Okay, yes, for one list. Now I'm going to remember how it's A. If I come over here and click, I could pick males. Notice fat is still in here because I'm still in the same document. I'm going to pick males, but this is the key. My column B is where my females data is. So I need to change this to column C because I need my answers to go in column C because that's empty. And I press OK. So the average was 62.4 for the males. Okay, their standard deviation was 71, a really high standard deviation. But when you look, their data is really spread out from 0 to 214 text messages. For females, I'm going to go menu, statistics, stat calculations, one variable statistics. I'm going to click here for females. Now the results are in C and D because the words are in C and the numbers are in D. So I'm going to put them in E. All right, E is empty. So then if I go to the right, I can see, all right, so males, the average was 62.4. Females, the average is 128. Their standard deviation is 116. Right, and here's their 5-number summary. So you'll notice I wrote it all down. I wrote the mean, the standard deviation, my 5-number summary for both. I did my IQR. I did Q3 minus Q1, 77. Q3 minus Q1, 157. So the middle 50% of males is spread out over 77 text messages. The middle 50% of females is spread out over 157 text messages. Yikes. When you graph them, okay, so when you graph them, you need one axis and you put the two graphs above and below each other. Do not do a graph for males with one axis. Start over, do a brand new axis for females because they need to be above each other so that you can clearly see the differences, right? Here's the median for males. Here's the median for females, which is almost the max besides the outliers. Now, you'll notice I didn't do an outlier test on my paper. I didn't write it down because I'm going to let my calculator do it for me. And this is where it gets so cool, right? So if I go to this, now again, to go back and forth, you can hit Control left or Control right, and it goes left and right on the tabs. You can also just take your cursor and scroll up and click on them. There's lots of ways to do the same thing. So I'm going to click males. And notice there are two outliers. This is where you need to pay attention to your data set. It looks like one, but males, if we go back to our list, males down here have two numbers up there. So you have to pay attention because if you only draw one outlier, you're wrong because there's two outliers in this data set. But what's really cool is if I go menu, plot properties, I can add an X variable and I can add females. Whoa. Now it gives me both graphs vertically above each other. So you could compare, if you're doing a report, you could just screenshot this. It's so nice. Notice males, the last data point was 127 before the outliers. Females, there's actually no outliers. This 379 was not considered to be extreme compared to all these other data points. Right? But 213 and 214 are considered extreme compared to the male data points. So this is a beautiful double box plot, right? Box plots for both females and males. Make sure that you label them. So now I didn't answer, and I gave you my Inspire trick. I didn't answer this, but this is huge. What conclusions should the students draw, right? Well, you need to state the obvious. The obvious is females text way more than males, according to this data set, all right? According to this data set, females text way more than males. Now we need evidence. We need to talk about why. So you could say, while they both have a minimum of 0, the Q1 was 28 points higher for females than males. The median was 99 points higher. Okay, no, that's wrong. 69? 79. I don't know. I'm having a subtraction moment. Q3, over 100 points higher. Max, 150 something points higher, 160 something points higher. Okay, you need to state the difference between them. You can't just say it's higher. You have to state how much higher it is. Okay, or say the male max was 214, whereas the female max was 379, which is much higher. Okay, you could talk about the averages. The female average was more than double the male average. Also, the females have a much wider spread than the males. So any of these things I'm saying are important. You could say that the third quartile is higher than almost every single male. The third quartile for females is higher than all but 2 of the male data points. So here's a quarter of the females, but here's only 2 of the males. Okay, the lowest quarter of females is the same, pretty much the same value as, it's actually higher than the lowest 50% of males. So this is half of the guys right here. Oops, this is half the guys, and this is only a quarter of the girls. This is half of the girls. This is 75% of the guys, right? Any of these things could be good sentences. You need to compare the centers. You need to compare the shapes. You need to compare the spreads. All right. I haven't talked about the shape yet. The more clumped up it is, that's where it would be a higher peak, right? That's where it's all the data points are clumped, and this would be spread out. If you come back to the graph, you can change this, right? You could do control menu, pick dot plot, and that's a nice way. If you have a data set, you could see the shape. Males, definitely right skew. Females, it's kind of spread out the same, maybe a uniform shape. Okay, so females, it's kind of uniformly spread out, where or symmetric, where it's pretty consistent the whole way. And if you look here, this is pretty consistent. Maybe some more clumped here. So maybe you could say this is also right skew. Looking here, you probably could, like, it's clumped and then this is spread out. This one is really down low next to it. It shouldn't be stacked. They just couldn't get the dots there with the pixels of the technology. Okay, so your homework problems for this are here. All right, that you're going to work on. Make sure you're understanding how they go together. And then these are the multiple choice that are important to do.